Hi, my name is Noah Gift, and I'm going to walk you through how to debug Python code. A lot of times you're stuck on, let's say, a couple hundred lines of code or 1,000 lines of code, and you've really made a lot of progress, and then something breaks, and it's really difficult to, know what to do next. And we're going to go through a few obvious and non-obvious ways to debug your code. A lot of times, if you use some things like maybe automated linting, for example, it seems like it's more work, but it's actually a good practice that will save you time. Another one is printing, doing debug statements, and then also simplifying your code, maybe pulling pieces of it out, or even this question that I like to say, which is, does anything work? Trying a little bit of your code, maybe writing a test for it, is a good way to get yourself out of trouble. So if you're struggling with something right now and you want to kind of get right to the solution very, very quickly, go ahead and stay tuned, and we'll get right into the techniques that will help you. To start with debugging Python code, I have a repo here called Noah Gift, Debugging Python. And to start with, there's really these four main points. First, continuous integration. I think this is one of the most common ways that people get themselves into trouble, and it's very easy to get yourself out by adding continuous integration, so we'll go through that. The next thing is printing or logging statements. This is an excellent way to debug Python code. And then pull out a debugger, so how to use the Python debugger. And then also installing IPython and importing parts of code and testing it out. And then finally getting into really writing a test to fix a problem. So we're going to go through all those solutions. I'm going to start with a Visual Studio Code space that's part of GitHub. This would work with any cloud-based development environment or even locally. And really the first thing that I like to do in a project is a scaffolding. So that means that I'll create a virtual environment first. So we'll go through here and say virtual env, and we'll call this debug. And the reason for this is that it isolates really obscure problems that could debug things, that could cause debugging issues. And really this is a very important part of debugging itself, is to have a clean environment you're working in. So both a virtual environment and potentially a cloud-based environment. This alone might solve a problem. So let's go ahead and source this. I'm going to say tilde/.debug bin activate. Great, got this thing set up here. And now what I'm going to do as well is add a little comment here that says, set up a virtual environment. So set up virtual env, right? A good way to debug code. So we'll do that. We'll say virtual env tilde debug. And then notice as well that I'm putting it inside of a home directory that's hidden so that I don't accidentally check it into my repo. That's another really common issue with building virtual environments, is you accidentally put them in somewhere. So there we go. We got this thing set up. Now, the first thing I'm going to do here is I'm going to create the scaffolding. That's going to be the next step, which is under continuous integration. And so I can just touch those files. This is a command that makes empty files. So we'll say touch makefile, touch requirements file, like this. And then we'll say touch app.py. So this would be whatever your application is. If you already have it, you can leave it. And then this would be a test file for later. And this is really the four files, I think, that are the key components to building a project that's easily debuggable. So next up, what I'm going to do is I'm going to go to a repo that I've already got some stuff inside, a little bit like a cooking show. I'm going to grab some of this and just throw it in. So I'm going to go to this makefile here, and I'm going to basically just throw this inside. Great. Now let's go through and walk through each one of these steps. So what this does is it installs the latest version of pip, and then also looks through the requirements file and installs that version. This is really key to debugging your code because it's a repeatable step that you can run locally, other people can use when they check out your repo, or inside of continuous integration, the build server will automatically test the installation. So this alone could be the reason why you have a problem, is that you just don't have the right package. And then additionally here, we can go through and look at a test, right? So this would go through and test your code. Formatting is always a good idea. This might highlight something you're having a problem with. And then lint. So I like to disable the maybe 2 verbose warnings, which are RNC, and I leave the warnings and the errors, which are really bad problems with your code. And this is essentially like a compiler for Python, in that it checks syntax, and this alone might just solve the problem that you're trying to solve. So these are really important steps here that I would recommend all projects have, because they really will save you time in the long run. So once we've got this set up here, the next thing I'm going to do is I'm going to grab some requirements. And so I'm going to go through another project I had recently and throw some project requirements in here. So let's go through here and do this. Here we go, pytest, pytest coverage, pylint, black. These are probably good ideas to install in your projects. And then also I think IPython is really a good thing to install, because it allows you to easily debug things in a REPL. Let's go through and do a make install now. So we'll go ahead and say make install. All right. Okay, now that we've got this installed, one little trick we can do to find the right version of IPython, if we want to pin those specific version numbers, which a lot of times it's a really good idea to pin the version number so other people can reproduce exactly what you did. So if you type in pip freeze, this will show you the latest versions of IPython, right? And we can find that, which is going to be this. So I'll go through and just swap that out. So now we've got this kind of dialed in here, but that's great. And now that I've got this set up, what I'll do is actually start to build out a really small scaffolding right here. So I'm going to make really the world's easiest function. We'll make it called add, and I'll put in a X and a Y here. And then I will basically return the X plus Y, right? So that would be what adding does. Great, this looks pretty good here. And what I'm going to do next is I'm going to put a print statement at the bottom that will just kind of run this thing, and we'll say, you know, print add 1 and 1. There we go. And let's go ahead and run this. So I'll type in Python app. There we go. So 1 and 1 equals 2. So this looks like things are going pretty well here. But as I mentioned, one thing that's really tricky is if you accidentally have some piece of code that's causing a problem, and how would you even check that out? Well, let's first see what happens when it's running in a clean way. So if I type in make lint here, right, everything is okay. But what happens if I add something really strange, like, for example, this is a subtle error that may eventually cause a problem in the future. Let's say I declare a variable, and then I say something like this. Like, why would I do this, right? It's kind of maybe I forgot that I was debugging something. And if we do make lint here, notice it says assign the same variable to itself, right? And so this even though the code will still run, if I go back here and I say Python app, that what's helpful about this is this shows you that eventually that's going to cause a problem for you, because it really doesn't do anything. And it could be the thing that later down the road is kind of hidden in there, almost like a time bomb. And this time bomb is going to actually rear its ugly head later. And that's why it's so critical to have, you know, automated linting set up. So I'm going to go ahead and comment that out. And again, if I type in make lint here, you can see that now things are back in business. So really the final step here that I would recommend would be that we can actually format the code. So I'm going to type in make format. There we go. We can see that it kind of cleaned it up a little bit. And then let's just build a really, really basic test. And so I can say from, you know, from hello, or from app, import add. There we go, like that. And then what's great about the way that testing works with pytest is that I can just say def test add like this, and then assert that something's true or false. So it's really intuitive, in fact, to test things out. There we go, assert 2 is equal to add 1 and 1. And if I type in make test here, we've got this thing going. And in fact, that is causing a problem because I didn't put 2 equals, right? Because it doesn't we can't assign it. We want to make sure that it's a quality. There we go. And we have 100% test coverage. So this is really the good, I would say, kind of the way I would maintain your project so that you prevent yourself from getting into trouble. And I put this comment inside of this project: if it's not automated, it's broken. So if you can't automatically lint your code, test your code, or format your code, you're in big trouble. You just don't know it yet. Eventually this will come back to haunt you. So right now, if you haven't done this, I would 100% recommend you do it. It's trivial, right, to set this up. So the next thing that I'm going to do is I'm going to actually tell a robot, which is the build server in GitHub Actions, to automatically test this for me. And I think this is a critical step to make sure that you do. So let's go ahead and check all this code in. So I'm going to say git status. Notice that there's these 4 files. I'm going to say git add star, and I'm going to commit this and say, you know, adding projects scaffold. There we go. This is great. We kind of got things in great shape here. And then if I go back to my GitHub project and I look at it, you can see all those files here. I'm going to go to actions, and then under actions, I'm going to say set up this workspace, and then I'm going to paste in a previous GitHub actions here that's kind of got everything I need. And let's go ahead and take a look at this. Whoops, we want to maybe go back here. Let's go ahead and set this up, and I'll go through here and just paste that in. Okay, so what does this do? Well, it does everything that we did earlier. It picks a specific version of Python, in this case Python 3.8. You could actually test it with multiple versions of Python as well. That's a really important thing if you're doing deployments to multiple targets. And then we do exactly what we did earlier. So I do a make install, I make lint, I make test, I make format. This is, again, in my opinion, the correct way to set up any project, a student project, a professional project, because of how simple it is and how much power it has in terms of proactively solving problems for you. So this alone might just solve your debugging issue. So let's go ahead and commit this, and let's kind of check this in here, and let's go to look at the action. Go ahead and look at this blank file. Go ahead and find this, and then once we get to this section, the next thing that I'm going to do is just double check that everything runs great. It looks like it runs okay, and we can just watch it as well, which is kind of nice. Every time it goes through, you'll see that each of those steps in the build process is being exercised for us. So that's the other thing that's really incredibly useful about automated testing, is that every single time I make a change, it's testing the installation, it's testing the linting, the syntax, it's actually testing the business logic, and it's formatting the code. Why would you not want to do this? It is really a best practice for debugging. And then if I go here, I can create a status badge. I can copy the status badge, put this inside of my project, and then other people on my team, or even me, I can realize, oh, whoops, I made a change here, and I caused a problem. So again, this is something that's a little bit of kind of a no-brainer that, you know, ironically, many people don't do, and that's why they get themselves into trouble. But let's assume that there's something deeper going on that for some reason doesn't get caught by lint or test. Okay, now what do you do? Well, one of the best ways by far, let's go ahead and pull these changes in so I have them here. One of the best ways by far is the classic print statement. So if I go through here and I'm like, I just really don't know what's going on, what do I do? How do I solve problems? Well, this is probably the canonical way to debug Python code. Go in, put a print statement. I like to use F strings here, so put an F right here, and then say this is the X right here, and just put in the name of the variable and put it into curly brackets like this, and it'll swap out that variable. And this, let's make it a little shorter. This is X, and then this is Y here, like this. And then we can also, if we wanted to, you know, basically maybe pull this into a variable to make it a little bit easier to print. And this is, I think, kind of a classic way to format your code. And we can say result. And notice that by printing it out, it kind of changes the structure of my code and makes it a little easier to debug, right? So if I go through here, I want to look at the variable that comes in, the variables that come in, plus I want to look at the result to debug it. So this is the X, this is the Y, and this is the result. There we go. And then I can do that and put these brackets in. So this alone might really get yourself out of trouble knowing how to write an F string. And so let's go ahead and try it out, right? So let's go through here and we'll say Python, and we'll type in add here, or Python app here. And notice that, look, it goes through here and it says this is the X1, this is the Y, and this is the result. But notice that, in fact, if I run make test, I caused an error. Look at that. So we know that, in fact, I broke the code. And this again shows us that there's multiple ways to kind of debug things. The lint will be just fine because there's no syntactical errors, but the business logic is wrong, right? So there's really these three different tools that I'm playing with. I have a print that shows me what's going on. I have a lint that checks for syntax, and then I have the test, which tests the business logic. So each one is a really powerful way to kind of figure out what's happening. Now, pretty easy to fix this, right? I just have to say result, return back that result variable here. And now if I run make test, make lint, make test, everything works. And then if I run Python, we can see that everything prints out here. So this is really, really helpful. And it seems almost too good to be true. It's like, is it really that simple? It's really that simple. So if you're building functions, I would definitely recommend having print statements like this where you put the variables in and you put the results in a syntax using an F string. And then if it's a production-based system, I would recommend using the Python logging library, which is a really useful library because it can be redirected to multiple outputs. But again, for kind of maybe basic code here, a print statement is great. Let's say you're a data scientist or machine learning engineer. So great, we got all this working here. Let's go ahead and check all this in. Let's go get status here. We can see this has changed. And then we can say git commit. So I think it's a really good idea before you commit your code to just test it locally, adding more debugging, but we just did. But what's awesome is that the build server is always going to be on the job like a robot. It's like a robotic security guard, right? It's going through, it's constantly doing everything I did locally. I don't have to worry about it. And it's going to go through and make sure that the new changes that I made, the installations are good, the linting is good, the business logic is good, everything's good. And if it's all done correctly, which it should be, then we will be able to get a kind of green lights here. So let's go through, everything's great, perfect. So what's nice now is that I can kind of proceed to maybe some further debugging. Let's say for some reason here that the debugging, you're still having a problem, which it can happen, right? You're kind of stuck. You're like, the printing is not showing me as much as I'd like. What else can I do? Well, there's still more weapons. And one of the weapons that's really the ultimate weapon in a sense is the Python debugger. And what you can do, there's even an IPython version, but in fact, let me just change this right here. It should be set trace. It's a function like that. And what we're going to do is we're just going to put this piece of code inside of our project, and it's basically it tells this function, hey, don't do anything, just stop right here. I want to kind of poke around a little bit and see what's happening. And so this is really something I've used in rare occasions, but it really can help in terms of debugging things. So let's go ahead and do that, right? I'm going to say Python, and we'll run app, and notice that it'll set a breakpoint on line 6. There we go. And now what's cool about this is I can just say, what's X? X is 1. What's Y? Y is 1. Great. Well, what happens? What about result? What's result? There is no result yet. Let's go to the next line. So let's do the in character, which in is for next. There we go. And now let's go ahead and do result. And you can even do up arrow, right? So you don't have to type as much. Result, okay, things look like they're working well. I don't need to debug anymore. And then you can just type in exit. So again here, what's powerful about this is that this is the ultimate weapon. If you're stuck, go in, use the Python debugger, and that might just get yourself out of a problem. Well, let's say, for example, you're still stuck and you still are having problems, or for some reason you're, maybe don't want to use the debugger. Let me show you yet one more trick, which is you can install IPython, which we already did before. And I think this is one of the better ways that I like to develop code, is especially if I'm dealing with, let's say, an API call to cloud computing, or kind of some other complex system, is I'll just import it with IPython. So I'll just say, from app, import add. From app, import add, like this. And now look, I've got this variable and I could just start testing things out, right? There we go. Oh, look, 2 and 2 is 4. That's great. Okay, what about this? 3. And then I could even start to build a function if I wanted to build a new function, like, okay, let's like make a double add or something. You could kind of go through here and try out some other function and start to build it out, and go add 1 and 1, and then this would be, for example, x here, and then we'd do y is this, and say add 2 and 2, and then we could go through here and say return xx plus yy. There we go. And then if I want to test it out, I can just go through here, right? Go double and just call it, right? And it's going to go, there we go. I'm going to put those two things together. So really, really handy way to kind of dig deep into your code and kind of try to figure out what's happening and get yourself out of trouble. In fact, I even develop like this. I'll like to build little functions, then put them in. So again, if I wanted to just kind of paste this in now, we all we have to do is basically just kind of clean it up a little bit. Let's go ahead and do that. Let's kind of, take this out here, right? And there's some cleaner ways to do this as well, but, just to kind of make it quick and dirty here, I can just delete this by pasting it in. There we go. And then there we go. Like this, and we can just delete this line. Okay, so now that I've got that, what I'm going to do is I'm going to tab so that it's proper formatting, and then there we go. So we've got another function here, and then maybe I even go through here and I just print a double or something, so that I've got 2 of them, and then I can go through here and exit this. Great, and I can type in Python app, and look, we got actually a syntax problem, right? So we were able to debug that. So again, this could be a great way to debug your code, is going through, and look, we can see that it didn't call it, right? So I can basically call this function. Is that you first build out pieces of it, or you import pieces of it, and put those pieces into your code. Now, the final thing that I'll mention here is, and again, I'll just kind of push these changes. So we'll go ahead and do this, git add. Is that what happens if you're really, really, really stuck? You're still stuck. Well, one of the things that you can do that I like to do, let's actually pull this changes here. Let's go ahead and merge these. So let's go ahead and save this. Great, and then go ahead and push. So one of the ways that I like to really get myself out of, let's say, 1,000 lines of code, is that you can test your way out. So let's say that you really have no idea if anything works. Just write one test, and this would be exactly the case, right? So let's pretend now that this is actually broken, and in fact that it instead is subtracting, right? We can say it's kind of subtracting here, and I go through and I say, Python, make test here, right? And you're like, this is horrible. Well, how can I fix this thing? Well, just get one thing working, right? So just get one test working, And that alone might really help you debug what's happening. So again, we can see here, why is this happening? Oh, look at it, I'm subtracting instead of adding, right? And basically the one test might be enough to just get kind of the whole thing working and getting that scaffolding together. So that's probably the final thing I would say, is if you have no testing. So you can do a lot, right? With the installation is helpful for debugging, the testing, the formatting is helpful for debugging, the linting is helpful for debugging, the IPython is helpful, the IPDB, but just writing one small test like this it's really a process of making the application less and less complex. And that's really the key here. And I'll even put this into the documentation, is the idea is that you want to reduce complexity. So this would be kind of the summary: reduce complexity. And this is really the essence of programming, is how can you make this script do less. And one way to do that is by adding a very small piece of code, having automation. These are all ways that you can debug your code. So I think through a combination of all these methods, they'll help you get yourself out of big trouble. And look forward to giving you some new tutorials in the future, but good luck on your project.